Good morning, science lovers. This is David D. Hilscher. A lot of you know me as a Dissident Science Guy YouTube channel, but I'm also a member of the CMPS, the John Chappell Natural Philosophy Society, and I want to welcome you here to another Saturday morning chat. It's going to be a great day. We're going to be talking to somebody new we haven't talked to before, Alistair Riddoch, and he's going to be talking about his theory today. And I just want to remind you about some of the things about what we're doing here, who we are. We are the Saturday Science Chats. We actually started in 2008 on a system called DimDim, believe it or not. And today we are using a wholly different system that goes live. We are right now going live to Dissident Science YouTube channel, to the CMPS YouTube channel, and to the CMPS Facebook page, where we have over 4,000 subscribers that have the ability to watch us. But these are our Saturday Science Chats. I've been taking over a little bit from Franklin Hugh, who had been doing this for a couple of years. Give him a break a little bit. But I want to tell you about what we are about, the CMPS, for those, especially those people who are dissident science. What we are about. Our mission is to be an organization that above all promotes critical thinking without malice, to be an organization that supports, publishes, and promotes serious scientific work outside mainstream, to provide a forum for debate about modern topics in physics, cosmology, philosophy, and mathematics, to provide a forum for presenting serious papers and theories without fear of censorship, and to be run and controlled in its entirety and by its paid membership, including the election of directors by its members. I happen to be one of the directors right now, but that is all, of course, up to the members themselves. We are based in a community online with our brand new website, naturalphilosophy.org. There you can go and see all about who we are, and actually that's our community now. It's got a great new software we're using called Buddy Boss, and allows you to go in, create your profile, and join into discussions. You can look at the activity feed. You can see all kinds of discussions, from discussions on ether theories, electrodynamics, people's own theories. You can see when things are happening. You can write blogs and all kinds of things. We have extensive websites, actually. And if you don't know our websites, you can visit it. Of course, our community website, which I just mentioned, naturalphilosophy.org. We have an online magazine, so if you're new to this and you want to read about what it is, what people outside the mainstream are doing in a way that's just like a very nice magazine, where you can read really interesting articles that are more to the layman, but there are some technical as well. You can go to sciencewoke.org. I would really highly recommend you go there if you're new to it, because it can really walk you through why so many of us realize that mainstream science has so many problems. We also have a wiki. You can go to wiki.naturalphilosophy.org, and we have over 10,000 pages of books. I think we have over 2,000 dissident books there. We have almost 3,000 dissident scientists there and their profiles. And of course, we have coming up our Chappell University, which was actually founded in 2018, but we haven't really gotten it off the ground, but we are now. We're going to be using LearnDash, a commercial software that works with WordPress, where we're going to be creating courses. We already have 2 professors lined up, hoping to have some more professors. I call them teachers. We'll just call them teachers, and they're going to be giving courses in natural philosophy. One big one who's going to be working and starting on his course will be James Maxlow. He's going to be Dr. James Maxlow. He's the Australian geologist who is an expansion tectonics. If you don't know about expansion tectonics, go to our Wikipedia and look up expansion tectonics. He's going to be putting together a course in expansion tectonics. He is the leading scientists in that area. And my father will be putting together a course on our particle model. So if you have your own model and you want to teach people what it's all about, and literally almost give a class to them online, we have all those as part of our services for those members. And of course, if you're a member, what can you do? Well, oops, go to it. Going the wrong way here. Sorry. How to participate. Oh man, you saw A preview of what I'm going to be talking about right before we talk with Alistair. This is how to participate and support our organization. You can sign up on naturalphilosophy.org. Just sign up. You have to verify your email and everything. It is secure. Consider becoming a member. We do have memberships, annual memberships that range from $35 and up. We have people who are retired, lots of retirees. So $35 a year, that helps support all of this going on, including this venue of our StreamYard. We pay $200 a year to have this kind of service, but it's really well worth it for the whole community. You'll be supporting not only yourself, but the community. And you can participate in the community discussions on our website. And you can also can help us out by posting news and happenings about us on social media, either on Facebook or wherever you happen to hang out. That is greatly helpful. So today I'm going to start something different. Before our talks, I'm going to give a little commentary. I think this is really important, especially for today's talk, because I've had people from our organization levy some criticisms toward why do we allow so many people in so many different models? Or why don't we come up with somebody we support and back them? Well, our job is not that at all, and I'm going to tell you why that's actually a very bad idea, and that's why science is stuck in the first place. So here's the problem. No one listens. Dissidents complain to me all the time that no one listens to what they have to say. Universities won't listen, of course, like Dr. James Maxlow. I said, why don't you teach a course in expansion tectonics in the university? They won't allow them in. Other dissidents, of course, won't listen to them as well. They come to our conferences, in-person conferences, and they go, well, people aren't paying attention. Well, that doesn't happen as much at our conferences. We didn't have one this year because of COVID, but we're planning to have our next in-person conference next year in 2021. And also a comment I got in the 2000s when we were meeting at the University of Connecticut in the mathematics department, where Dr. Eberly Spencer had hosted many of our dissident science conferences. I had two Finnish scientists come and they gave a paper to our organization. And it turned out that when I talked with them, they go, this organization has all salesmen and no buyers. And these are problems. These are real problems. We need to deal with these. Universities are failing us. This is an absolute truth. Universities do not allow for dissent. They don't. Unfortunately, that's sad. That's absolutely the opposite of what universities should be. They create conformists, and that's not good either. That doesn't allow for growth. They teach truth instead of teaching, and that's a big problem. And that is, if someone comes to me and says, Dave, you do all this stuff, your father and yourself are writing a book on the model of the universe, so what degrees in physics do you have? Like they would allow us anyways. They won't allow us because we will not conform. We have different ideas. We have a different model of the universe. Even though it's based on Newton, they won't let us in. And they do not create critical thinkers. And this is from one of it's a t-shirt from one of our conferences, Critical Thinkers. I love this one. And so those are problems. Of course, science journalism and journalists and evangelists also fail. They push the mainstream narrative to keep their jobs. And actually, I didn't put down the most important is to look smart. Neil deGrasse Tyson, which I am not a big fan of, is something that someone that is out there always pushing the mainstream and laughs at anybody who tries to say, for instance, Einstein is wrong. They do not question mainstream science, or they lose their jobs. They know that. So if you are a science reporter on some big mainstream channel and you decide to go and start challenging Einstein, of course, that ain't going to be good for your job. And keeping your job is a lot of times the number one thing that that motivate people, putting, as one person said, food on the table. They do not bring up, the journalists and the evangelists do not bring up clear contradictions to mainstream theory to universities and prize givers like the Nobel Prize. The Nobel Prize is given out, especially in physics, to things that are absolutely bad science. Physics is notorious for that. Chemistry, no. Chemistry and astronomy, well, astronomy a little bit today and age, but chemistry and other things aren't so bad because they're not based on theoretical things that no one understands. And of course, science journalists and evangelists, they often really are seeking fame more than they are for seeking truth. Of course, we have the failure of we dissidents, so we should not be very proud either. They or we do not listen to one another, because I include myself in that. We criticize other dissidents in the same way universities and mainstream science criticize us. I'm changing all the, sorry about that, put these together this morning, but that's true. And we sit there and I have a very, I won't say his name, a scientist I admire greatly. He's in his 80s. I talked to him on the phone. He says, Dave, the big difference between me and you is that I don't accept all these crazy theories and crazy ideas. And I go, well, that's not the problem. I mean, that is the problem. It's not that you have to accept them, is that we have to give them a voice. And if we don't give them a voice, why would we give you a voice over them? And that's one of the problems. So we are hypocritical, and that has to change as well. The CMPS and dissident science, CMPS being and dissident science being the some of the sponsors of this Saturday night. Well, it depends on where you are. Saturday morning science chats. Our goals are the same because I'm dissident science. I appreciate all my subscribers tuning in, and we give a voice to all with serious scientific proposals, like Dr. James Maxlow, like Alistair. He's put together for many years his ideas about how the universe works. We provide support and we provide them support and a platform. That's really important. That's what we in the CMPS do. That's what I do in dissident science. You can go to all those other science channels and they're all talking about the same things and things that a lot of people just don't really like or believe in because they think it's a lot crazy. And you're going to be able to come to my channel and see people who are critical thinkers giving different ideas. We also encourage dissidents to listen to each other. That's really important. And that's what I'm going to talk a little bit here before we bring on Alistair. We also, those dissidents who do listen to others are more successful. And that is a fact. I know this because I've been doing this for almost 30 years. The best scientists I've met in the MPA and in the CMPS since 1996 are those who, most of them are engineers. And I'm going to tell you why that is. And I think this is, what's so special about them? Well, it's what I call an engineering attitude. And this engineering attitude is what I see. These are the people who go furthest in science all the time. They look for solutions, not to be right. And that's one of the big problems. The problem is if I got my own theory or my own model, I'm right and you're wrong. And I'm going to explain why you are right and you're wrong. I have these arguments on our own website at naturalphilosophy.org. I see some of my dissident friends out there giving absolute statements, meaning they are right. And the problem is we need to get away from trying to be right, and we need to try to look for the solutions. Every engineer knows that everyone is wrong. Engineers know this, and they take that for granted. Some are just less wrong. There is no right answer. Remember, there are many solutions to the same problems. Engineers know this. So what they do is they fight each other, and they go, okay, seems like to be the best answer. We don't do that. Somebody has their own theory, and a bunch of people come up to you. Let's say you have your own theory, and they say, hey, this is pretty interesting, but we all agree this part is really weird. And this has a problem. It's got a logical problem. You should look at that. Oh, no, it's you guys just don't understand my theory. That you're not going to get anywhere that way. You're going to be stuck and worse. And I'm going to tell you, I didn't write this down. I tell people all the time. They're going to take your theory and those ideas and make them better and use it. And you're going to tell them, oh, you stole my idea. Well, they stole it and made it better. I know, because my father and I are based on Nell Deneu's work, on Glenn Borkard's work, on other people's work, Lesage, Newton, all of those people. We stand on each other's shoulders. So you got to be careful. This is also a very important point. You will be wrong, and you have to admit it and move on. That's just a fact. And that's the big one. People will not do that. They'll dig their heels in. They're going to say that they are correct, and they are going to just say, I'm sorry, my theory says this. I don't care what you say. I tell people in ether, you have to do transverse waves, and then people say, I can do it this way. That doesn't work. They just don't listen. And it doesn't mean I'm right or wrong. I'm pointing out a problem. And those who are not etherists who look at that go, yeah, that is a problem. How are you going to deal with that? But no, that's okay. Again, you will be wrong. You have to admit it and move on. Listening to those thinking different often leads to better solutions. Absolutely. It jars your brain. It gets you out. If you are a person, even with your own theory or your own model, it's great. Every time a person like Alistair shows up with something I've never seen, I dig into that like crazy, as if they had discovered the holy grail of science and they're going to be the next Nobel Prize winner. I don't know. It could be true. But we don't have that attitude. That's sort of like a childlike attitude where you really want to say, hey, somebody spent a lot of time doing this. It must have some value. And you never know. Okay, so if we censor, we are no better. That is, if I come in and say, look at Alistair's work and say, Alistair, that's crazy. How could you have everything out of this one particle? I mean, I have a philosophical difference with that myself. But if I do that, I'm censoring it. Who says I'm right and he's wrong, or he's right and I'm wrong? We must change the way we go about science. We must change. If a person's in a university and they want to come up with a new model of the universe, do it. Do they let them? No, because it doesn't agree. What they do, they indoctrinate you so that you know what they think, right or wrong. Okay? And this is really important. We all get on our high horses and we think, and this is something I just really came to the realization in the last year, and this is something I want to pound into your heads. History is the judge, not us. It's not everybody who is here today. We're maybe 20 to 30 people online live right now, and all the people watching who are going to watch this recorded. I mean, you're going to be eventually thousands of people. Are we 1,000 people, the judges, to tell anyone that Alistair and his model is right or wrong? No. I mean, we should be free to pursue our truths and let history. If your stuff is so good, everyone's going to grab onto it, and people are going to say, "Wow, this works," and it's going to happen. But we're not the judge, so don't. Everybody gets on their high horses. I know this isn't going to be it. You don't get the vote. Think about it. So, what do we need to do? Like engineers, what I do, this is sort of the way I look at it. This is like, you see this little childlike halo over their heads. This is a childlike attitude. If you have a little kid like 5, 6, 7, 8 years old, and they're still pretty innocent, and they like science, like the kid likes science, likes making things and all that, and you say, hey, I know this guy who has a new idea of how the universe works. They're going to go, oh, cool. They're not going to go, oh, is he from a university? They don't care. They judge themselves. We need to learn to love and embrace those who think differently. It makes new and unexpected connections in your neural network. We know for a fact how the brain works. We know very well. We simulate it. I work for a supercomputer department at LexisNexis, and we have people doing machine learning with neural networks. We know how they do. And if you keep adding different types of faces for it to recognize different faces, the more different faces you give it, the better it gets. So if it's the more things we expose ourselves that are different from us, the better we're going to get. And that's truly what you need to remember. Change your attitude. Start today. Start with Alistair. And if you're one of those people, oh, I'm not going to listen to somebody, I know how the universe, well, guess what? You're going to relegate yourself to the flat earth society. You're going to relegate yourself to being someone who's not going to, who's going to in history be looked upon, oh, they're just one of the masses who are afraid to look at the new ideas that were coming. That's true. So anyway, that's my commentary for today. I think it's really important because so many people, even in our organization, say, why do you have this person with this crazy idea? Well, guess what? You know, we need to support everybody. We need people to have the ability and not have the fear to talk about what they do. And if you are also one of those people like Alistair, he has to have not have the fear that, well, this is a working and growing and changing model. And that's really important. I talked with him on the phone before we had we're going to be talking with him shortly. And that was one of these things, it's changing. I go, wow, that's good. Because if it's changing, that's good. My dad and I have been writing our book for about a year and a half now, well, 5 years actually, and it's still changing. And then as I make graphics, we change things because we're constantly evolving. So if you are a person, you got to get unstuck from that and get to a point where, hey, open your mind. Let's look at something different, like the Planck mechanical theory by Alistair Riddoch. And that's one of the things is very important this is one of the theories that I've been talking about in the sense of here's a person who spent many years on their theory, and we're going to take a look at it today. I'm excited because I always learn something. Who knows? This guy may be the one, and he may have the answer, or he may be the one that sparks the answer from somebody else. We don't know, and we're not going to go anywhere if we don't give a forum to these people. We're the place to do that. So I wrote a little bit down here. He can totally correct me on this because I've just got to know him. Well, from my conversation, he is a Canadian inventor, entrepreneur, scientist. Alistair has worked in many fields. He's became interested in physics because he says his mind can't stop putting things together. And I've met a lot of people like that. And he said he has talked to his theory with several physicists, at least one I know in a university, I think it was in Pakistan, communicated with him and abroad, and he also likes to answer questions on Quora. I think my father also likes to do that. So anyways, without further ado, I'm going to be bringing up Alistair, and I want everybody to welcome him. So I'm going to bring you up. Alistair, welcome.
Hi, everybody. And thank you, David, very much for the opportunity to... Am I live? Like, you can hear me okay?
Yeah, absolutely.
Okay,
No
good.
problem. No problem.
It's the headphones. Just making
Yeah.
sure.
Yeah, no, I heard, just give you a little bit of background. I talked with you on the phone extensively last night, sort of in what I do pre-interviews. But you've been hanging out in these Saturday morning chats for a while, right?
Yes. Yeah,
And
quite a
so,
while.
yeah. And so he said he's been, coming in, watching. Franklin has been in charge of that. And we also have other guests, like I think Dr. William, can't remember, Dr. Bill. He was also, 60 years old, I'm forgetting the names. He also, I think, hosted a lot of times. And tell me a little bit, well, before we go in, because I know we're going to talk about your ideas. And I know you said it's not going to take a whole 2 hours, but give the audience a little bit of idea of how you came here. I mean, obviously every human being wonders about the universe, but how did Alistair start thinking, hey, I may have a model that people may be interested. I may be seeing the way that the universe works. Give a little backstory as to how you got to where you got in your model.
Sure. A lot of my career has been uh, analyzing data or solving problems in network security programs. And when you program a computer, you don't get to be close to correct. If there's a bug in the program, you find it, and you have to find it. You don't have any choice. So you develop the ability to solve problems. And so I did a lot of computer work, a lot of material analysis, that sort of thing. And then a while back, what really got me, I guess, interested in looking for a solution to the nature of gravity was the rise of concerns about the climate. And I saw two sides, saying, hey, this is how things are, and these guys, this is how things are. And when I see two sides that are large and both well considered that can't agree, I look for the pieces in the middle where they do agree, and the pieces where they either don't agree or they just neither of them maybe no. Anytime there's competing uh, philosophies, you look for the common ground and the non-common ground, because in the non-common ground is often where the reason why the two groups are going like this instead of like this is because of that piece that neither of them have. So when I looked at the climate, I have a bit of a history with working with pneumatics and taking some schooling in that, and so I have a, a fair understanding of pressure and volume and temperature and such. So what I knew was that the more you squeeze air, the hotter it gets. And the atmosphere is constantly squeezed by one thing, gravity. And when I looked into the nature of gravity, I mean, I already kind of had the idea that it was not very well resolved. And I've never been a fan of a universe that has a start date. So I always had questions about relativity and the fourth dimension and time dilation and contraction, and wondered maybe there's another answer for like decades. And then, so with the questions about climate and the mystery about the nature of gravity, I started to look into that. And when I was exploring the nature of gravity, you look at all the work that everybody has done. I mean, thousands of people have attacked the problem. So I looked at and everybody's attacking it the same way. They're looking at the big stuff and getting smaller and smaller and smaller and smaller. And that's like, okay, there are people with hadron colliders and satellites and LIGO detectors and dark energy detectors and math skills coming out of their wazoo. If that was the direction to go, why were there 24 candidate theories in the list in Wikipedia, not one? So I just went the other direction. I just wiped the whole thing clean. Nothing on the paper.
When was it?
Nothing.
When was this, Alistair?
That would have
What?
been in about November of 2013.
Okay, so that's incredible, because one of the things that's really interesting, that one of my favorite, one of the probably my favorite philosopher, one of my favorite philosophers in natural philosophy, Dr. Glenn Borkard, he said, it's not it's relativity, for instance, is a theory that has never had that it's broken records as to how many people write outside of mainstream against that. That is, so many people. If the theory was so correct, like relativity, why are there literally 10,000 books, papers, and thousands of scientists outside mainstream criticizing and coming to the same conclusions? And that's really amazing to me. One of the things that gives me hope and faith is that I meet really great critical thinkers, even like yourself, and people who have been through the same thing, like myself and thousands of others. They go through this same, this idea that the universe has a start date. I love that. I've never heard that way put it before. But you're talking to a crowd that is basically trying to find the truth. So that's really interesting. So tell us how, before we get into your talk, tell us how then from that. I appreciate the story. It always helps people who also think that way but don't know, hey, do other people question these things? Tell us how you got to actually this Planck mechanical theory before we actually talk to him. Can you give us a brief, not too long, but a brief
Yes.
idea of how did you come with this idea that you're going to be presenting today?
Definitely. You hamper me a little bit by asking me to not be sharing my screen while talking, but so I decided to look wipe the slate screen clean.
Well, wait a minute. Wait a minute. If you want to show your screen and start
No,
out, let's
that's
go
okay.
do it.
It's okay.
I think
Okay.
it's more of I think what I want is more of the story of your
Yeah.
logic, how you got there,
Yes.
and I mean, here it's one thing to question. I mean, I'm sure millions of people question Big Bang because I mean, people think, come on, it's all exploded from nothing, and it's what's around it, not universe, and all kinds of stuff. There's millions of people who think that, but there's not millions of people who
The,
come up with a model. Why did you go from
well,
the criticism to actually coming up with a model?
I I didn't set out to say that the Big Bang is wrong. It never felt right. So it wasn't like looking to prove anything wrong. I wanted to know what is. And I don't care if there's a Big Bang or not, but I don't know why people would stick to the conclusion that there's a Big Bang, but they can't tell you what existence is made out of, and there's 24 guesses as to what existence might be made out of, but they want to claim they can tell you something that happened 14 billion years ago. So I don't know why anybody would cling on to the Big Bang until we know what everything's made out of, and then decide what does that tell us about everything else. It's premature to conclude about something that is supposedly 42 billion light years distant that way, and 14.86 billion years time that way. And there's a star 190 light years from Earth. So that's 190 out of 92 billion in circumference, or sorry, in diameter. 190 light years from Earth is a star that our best estimate says is 400 million years older than the universe. So, and it's so close to us, like that close, then out there in the other 300 billion trillion stars we have not yet analyzed, we've only analyzed, I don't know, 100,000 or 100 million or something. There are hundreds of trillions of billions that are observable. What's the chance that the oldest one happens to be this close to Earth out of the vastness? So just from observable evidence, and then there's the whole thing with the spiral arms and relativity
Right.
not properly predicting it. And then instead of saying, oh, maybe there's an issue with relativity, they're like, here, let's just shove some stuff in, that'll fix it.
Yeah.
And they haven't
Yes.
detected the stuff. So
Right.
there's reasons to question relativity.
Sure.
Quantum mechanics, a lot more proven, but it's missing gravity.
Sure. So, okay. So, what we're going to do now is to get
Oh, you
into,
wanted story.
yeah, of course. What? Oh,
Sorry.
no problem. I know you can go
Well,
on.
there's
And
a
one,
really important part coming.
okay. Did you want to start your talk or did you want to finish this and then
Finish
start?
the story. It's
Okay.
important.
Got you. No problem. Absolutely.
It'll set the right tone for people reacting to what I say in like, yeah, this guy's not a physicist, didn't go to school and all that. I got an answer for that. So I wiped the slate clean and I started considering what could fill up existence. And you try all the different things in your mind. I put square blocks, rectangular blocks, trapezoids, everything. All the geometric Galilean solids or whatever they're called. And of course, you have issues with rotation if it's not spherical or egg-shaped or elliptical or something like that. So you're going to come back to spheres if you're going to fill space and want them to be able to rotate versus just vibrate. They need to have a shape that allows rotation. So I came to spheres, but I had issue with spheres because when spheres rotate, if there's friction, they can't. If there's not friction, when this one rotates, there's nothing going to affect this one because there's no friction. So there's very limited transmission of anything if you have only spheres. So then I began thinking maybe it's like a semi-friction, or maybe they turn not against each other like this, but maybe they turn at angles, or maybe they wiggle when they turn, or maybe they follow a line, like on a tennis ball, you know how it's got that sort of infinity line around it. So maybe they follow some kind of wiggly motion. It didn't feel right. So I wasn't really getting anywhere. Then one day, girlfriend and I are at the drugstore. She's waiting for a prescription to get filled. I'm bored. She's probably looking at cosmetics or something. Then I'm browsing the magazine rack, and I want to share my screen now. Is that possible? Perfect. So this is where I really need the visual, because what happened was, see, I put an origin story with some pictures that help. So I came across this magazine in the rack at the Shoppers Drug Mart, May of 2014, A Crisis in Physics. It was like, yeah, I'm buying that. And I probably buy a magazine every 5 years. I bought that one. The cover story about the crisis in physics, big disappointment. Then there was this other story about the CMB, and it had this shape. And so that's where the shape comes from. I didn't calculate it, I didn't conceive it, I didn't contrive it. I just found it in a magazine. It fit what I was looking for. You know, you got a jigsaw puzzle and there's only one piece missing, and that piece says you're gonna have to look like this shape. It just felt right. So I asked myself the question, with my clean slate, what if I had bajillions of those and they were all stacked in a pattern, and then instead of there being free space, all the transmissions are like direct nearest neighbor coupling, but then you're adding in a twist. You're adding in an ability. I need to switch to a different. So anyway, we were talking story. So that's the story of how the question in my mind came to be: could these, as a solid physical, mechanical, and I'm going to use a critical word, um, immutable. Sorry, I need to take a sip. Immutability means it doesn't change. It doesn't flex. It doesn't bend. It doesn't permeate. It doesn't shrink or grow. It doesn't radiate. It doesn't absorb. It is solid, like concrete, one single consistent, dense unibody, and it never changes. The reason that's important is if you fill up, do I have control over unsharing my screen by saying stop screen? If I want to wave my hands? Perfect. So if you fill up space with particles that never, ever, ever change, time is not a flowing property within space, because everywhere is always, sorry, let's look at it from the other perspective. If a particle never changes, then it's immune to time. It doesn't care. It's never changing. So if a trillion years pass or 800, it just doesn't matter. It's not going to change. So you have now filled up space with an immutable, timeless particle. What does change is that they move. So then you have a solid unit. Think of it like digital, but it's got the specific shape. Its motion is continuous and analog. So now you've got a dual property medium that's both digital and analog. It is eternal, yet it has flow of time as part of the flow of motion. So you've put time in there, but you haven't made it something that can change. You've made time tied in with motion, and since distance is it takes time for anything to travel across a distance, so time is fixed in a sense. It becomes buildable instead of needing to be an extra dimension. Then you ask, well, but what about this four dimensionality thing? So let's and sorry, I've admitted in a sense that I found the particle. So right there, that was like 1,000% luck. I was looking, and I maybe recognized if it is a fundamental, if it is the fundamental unit, then I managed to recognize. But I didn't calculate it or contract. I didn't think it into being. I lucked into it. So if there's any, oh, this guy thinks he's not a physicist, but well, okay, but a physicist made this. A guy looking at the CMB and analyzing the CMB made it. So it's got credentials that I get to borrow as saying, hey, look at this thing. And it's got credentials from right within academic science. I just got lucky and found it, got lucky and managed to recognize it if I haven't falsely recognized something that is useless. So if I make the mistake of saying I think this is the answer, don't think of it as, yeah, of course it could be wrong, and I know that. I just you make the mistake of you are geared towards investigating, could this be the answer? So in your head, one of my friends recently, his daughter moved out mad at him because she's decided that she's going to be gender fluid and want to have the pronoun Z used in reference to her or call her they. And he's my age, in his 50s, and he slipped and called her she, and he said, I'm sorry. And he said, it's like when you were kids and I'm calling for John and I call Jen, Jim, Bob, John, and I just made a mistake and I'm sorry. And the guy is absolutely not in any way prejudiced at all. He's 100% open, but she took it the wrong way. It wasn't intentional. He wasn't meaning anything. So if I make the mistake of saying, hey, I think this is the answer, understand that if I didn't think it was the answer, would I be spending time working on it? No, because, so forgive me for.
That's not, it's understood. What we have to understand is while a person is doing this, we have to, even when you watch, the only way I can watch anybody talk about a different model, yeah, you need to share your screen again, because for some reason, if you could do that while I'm talking a little bit.
Oh, sure.
Yeah, you need to share your screen. But one of the things I always mention to people is that you have to go along with the ride. If a person's talking about something, you don't have to sit there and everything a person's saying, everything you're saying, I have to understand completely, accept completely to go on. No, I mean, the idea is let the person talk in the world and model that they are doing. Let's assume that this is the way the world works and see what happens. That's all any of us can do. I mean, all of us who have different models or different ideas of how the universe works. I mean, all we can do is say, okay, we've got this model. How good is it? And this is the way it works. Now, as you said, again, as I say, you and I are not the judges of this. You and I, you could be completely right and everybody wrong in the end, in the sense of in 100 years, they're all going to be looking to you as the person who found the particle. But right now, as we try to understand it, it's like a movie, right? When you go into a movie, you don't sit there and go, well, there is no magic. So what am I going to watch Harry Potter for? And then you can sit there and not watch it the whole time. But what you need to do is say, okay, I know there's not magic, but I'm going to live in this world. How does it work? What is it going to say to me? Are there lessons to be learned? And that's what you need to do. So don't apologize for that. We understand that. So I see you got your screen back up. So I'm going to add this to the stream again. And
And
go ahead.
so this was just to kind of explain a little bit about some of the aspects of things that I have absorbed, but which I can't provide you the math with, but yet I would definitely call myself a master of that particular needed mathematical relationships. For example, I lawn bowled for 7 years. Now I put this upside down on purpose. One side of the bowl is different than the other, so it always curves. And the slower it bowls, the more it curves, a lot like decaying particles. Um, I played pool for thousands of hours. And there are things involved like throwing the ball that a lot of people wouldn't know about, but it's easily understood from a physicist's perspective or an engineer's. You're going to put right spin on the ball so that when it hits here, it's actually going to grab the ball a little bit and shift it this way, just a touch. There are other things you learn, like if a ball is on the rail, you hit the rail with right spin, so your ball hits and then shoots that way because of the spin, and the object ball you're aiming at just going to go zing straight in that pocket every time. These are things that if you're going to be good at the game, you're going to have to learn them. And it got to the point where when I see other people shooting, I know how their shot's going to turn out more often, well, at least as often or more often than they do, just from looking at their cue, the angle of it, the way they got their body bent and stuff. And you can see by where they're looking, their eyes, what they're planning and what they're hoping for. It got very second nature. And then the other thing I did for a lot of years was alley bowling. And I don't know if a lot of people know that inside of the ball is not uniform density. There are weight blocks inside of them. These are you guys can see my mouse moving, right? So these are very new and feature rich. We used to have, they were more like this, but you could still do some tricks. When you drill holes in the ball, you're taking away some weight. So there is a weight block, like this red one, oops, where extra weight is, so that when you take away weight, you don't overly lopside the ball. Then they've started to make these shapes, which will, as the ball rolls, at first it slides, then it starts to, the slide and the spin that you've put on it start to turn into a roll, and the two motions become one motion. So the spin and the forward momentum and the forward roll combine, so it picks up speed and hits the pocket at a higher pace with more intensity, and you'll get more strike. I bowled at 180 average, so I'm getting maybe 7-8 strikes in a game on a pretty regular basis. I can see the way momentum and sliding on the oil on the alley and the grip I see how they come together. I'm just trying to get you guys to kind of understand that I didn't approach it by calculation. I approached it by kind of like feeling my way there, and by luckily finding the magazine that was really like a lottery ticket if it has value. The guys that came up with the shape, it's a combination of oscillations that were detected in the cosmic microwave background. Guys that came up with it, they aren't proposing it as a universal building block or anything solid. It's just a pattern of waves put together from things that they detected. So I'll show you that next, because I think that's where it gets pretty cool. So it came from a project called Bicep, and Bicep was put together to look at the cosmic microwave background. We could use this one. It'll be a little
Alistair,
small.
just
Yeah,
before you go on, just want
sure.
to, all of these things are coming from our website, right?
Yes.
Okay, so for those who want to follow along, they can. You just go to, this is one of the great things about our new website. It's on his, he made a group for his Planck mechanical theory. And in there, you put some photo albums, right?
Yes, and the photo
Oh,
albums are
right,
categorized to kind of group the images together
right.
to
Okay,
to to
right.
help see.
Okay, so that's really interesting. This is the first time someone's used our website to present. So, okay, just that was just an aside. Keep going there.
Sure,
Thank you.
and
Okay.
and so I'm just bringing up this one because it shows the CMB on the right. So that is the detected, observed, measured cosmic microwave background. It's basically when you look out at the night sky, everywhere where there isn't a star or galaxy, there's just this faint heat. But the faint heat has patterns in it. And those patterns have specific names and shapes. And I'll show them to you next. So when we look at the cosmic microwave background, the next button, bonus. Okay, so we see this gets analyzed down into this, which is also this. And those are called an E mode wave. And that's up here. An E mode looks like that. And a B mode looks like this. If you take those and you smack them together mathematically, it makes this. And I didn't know that when I first saw the shape. So I saw the shape and I put it in a group of a bunch of them. And I asked myself, could this shape explain existence? Then I found out this. And I remembered back from school that this one here especially reminded me that, that looks like an atom. So I was like, yeah, those are the wave functions of hydrogen orbitals, right? And then over the past year, so I've been now looking at existence, looking at all the theories I can look at, looking at all the observations, and just kind of piecing them together. And so these are some of the observations I found that definitely exhibit the E mode shape. If you look at the shape of the Oort cloud and the asteroids and stuff inside, it shows it in both ways. And this one surprised me. It turns out that spiral galaxies, if they're viewed in the, I don't know, gamma ray spectrum band or something, we found out there are these massive, I mean, like ginormous clouds above and below. And what those turn out to be is they're like spray ejection out from the poles of black holes, which spray out and then create this because they spin around, so they're always going like a hose, and they create this shape. Is the shape of the Milky Way, or at least there is definitely a strong relationship there. Obviously, um, so that was around when I was finding these things out that it was an E mode and a B mode. That got me excited. Um, and then I came across I don't know who will know it or not. There's David Bohm and Louis de Broglie. De Broglie. They made a theory called pilot wave theory, and it has a fundamental unit, which is a group wave that then has interaction patterns, and you put that together, and it creates a field that they suggest is all else. And when you look at it, you can see you take the E mode right in there, you take the one that's more balanced out, B mode, look at this and compare it to this. If you were to take this and blow it up like a balloon, I suggest that's what it would end up looking like. And this is something interesting that I want to show too is See, this is like a dipole wave. So when you make it over to here, see how there are 6 sort of poles? That's something I'm going to suggest about this shape, is that in a sense, it can be considered octopolar, but because there's pairings of poles, it ends up being kind of like 6 poles and 4 poles, depending on which way you're using it. But okay, I made an agreement with myself to try and show lots and say not too much, because sometimes it ends up sounding like word salad. So I'm just going to try and show stuff and let you see, versus me trying to tell you what to see to a degree. I mean, I'll point out what I saw that got me excited. So I saw strong relationships here, and this is one of the sort of accepted alternates to quantum mechanics. Like, it's a very strong competitor as a underlying, like string theory and such. So that got me excited to see those patterns. So that was a bit about the E mode, B mode aspect of it. And oh, this is important. So I should make sure that I'm clear that what we're talking about is a physical and mechanical substrate, which is then energized with motion, and which then generates and hosts patterns which become structurally sound enough to be deemed as physical objects, even though they're actually kind of like energy objects propagating through an energy field hosted by a mechanical field. So in this particular folder, what I put was things that I think just kind of requesting, or not requesting, but saying, I'm looking at this from a different angle, kind of. So here's one, for example, and it says this would be zero energy. And when you move it, you've got energy, and whatever else we have that we call energy, the fundamental energy unit, if you want, would be, I suggest, this container in motion. So all energy has a body hosting it, or multiple bodies hosting it as a pattern set, versus there ever being any energy that is bodiless, is a part of the suggestion. Now, within the field, there are going to be patterns that will act as bodiless energy fields, and they are energy fields, but they're not bodiless because they're generated and hosted, is the suggestion. And that's one of the reasons why I like the solution, is that there are no forces, there are no energy, that nothing is inserted that has any variability, any opportunity to be misconstrued or misinterpreted. It's one solid, mathematically exactly described shape, replicated a bunch of times, add motion, and wait and see if it works. And so I'm confident that that's what's going to happen, is that you mathematically extrapolate from the interactions, the sorry, I don't know if when I'm sharing my screen, can you also see my little screen? I can't hear you.
Sorry, I keep it muted while you're talking.
Sure.
Yeah, I'm not sure what you mean by the little screen, but that screen is gone now.
Me, because sometimes I'm waving my hands
Oh, no, no, no,
and
no. What
I
happens
think
is,
nobody can see me.
no, no. As you're talking, I have your small
Okay, perfect.
thing right next to it. So, okay,
Okay, good, good, good,
sure,
great.
sure.
So So a few of the important things to keep in mind is that part of the suggestion is these, oh, share screen. So important parts of the suggestion are these are solid, they don't change, so they almost like don't count towards time. They're just there. And they didn't get created, they always were there. And when we look at the CMB, we're not seeing a heat signature from a big bang, we're seeing an interference pattern cast by the very medium that they exactly mathematically point back to. So it's like it all just kind of came together and makes a lot of sense. So then the next point is objects. So we're talking now atomic objects like quantum and macro scaled objects. None of them are an assembly of the underlying units. They're all free to flow back and forth through there. Like they propagate through rather than carrying it through like a sack of potatoes, because then you've got your assembly trying to push through, and that's not okay. So instead, there's this field that is locked. I got to try and get my hands just right. You guys can tell I'm not a professional speaker, I'm guessing here, eh? So when you see them that they're going to be slightly inside of each other, and when they're in motion, because one side is phase shifted from the other, for them to all turn, they're going to have to wiggle as they turn like this. So all of them are going to have an up and down oscillation as they turn. So they're kind of going to be putting an ellipse against each other, kind of like this in a way. So it's this up and down, plus there will be some forward and back, plus some in and out. They all mash together into this. It's like a vibration that's one way I like to think of it is line dancers, where if they're all doing the same thing, great. But then maybe your barn is full of line dancers and you get a new dancer comes in the side, he shoves somebody, then it's like this trickle effect where they're all still doing their dance, but they're also a wave of shoving going through the motion. Or another way to analogize it is to think of a tsunami wave. So you ask the question, what's a tsunami made out of? Uh, 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 an earthquake happens in Japan. Energy gets added to the water that already has energy and particles for the purpose of this analogy. And the vibration adds a shock wave. The shock wave goes through the pre-existing particles that already have vibration, goes through, and then they go back to being as they were. But the tsunami acts like a structure propagating. It's not made of water, it's not made of energy, it's made out of variation. So we're going to call the tsunami an information set. So think of things above the Planck scale as information sets, not as physical particles. So think of them as information. I think that quantum mechanics is going to be found to include a lot of cavitation, where the things go like out and then collect, and then out and then collect, and out and then collect as they propagate through. But I don't know exactly for sure how the mathematics are going to tie in. I'm just confident that the inherent patterns and the inherent resulting potential patterns have so many matching parallels into reality. I haven't seen something in reality that I could say, huh, that's going to be like tough to figure out a way of explaining that. I mean, I'm certainly not aware of everything in the world, but I sure have tried. One of the things I put in the backstory, if it's still there, is the way I work is I told you I absorb imagery and patterns a lot. So I have collections of folders of images. One of them's got like a few thousand where I go looking at, the Hadron Collider or the gravity waves or the atomic orbitals or E8 theory. And if I see images that I think may somewhat or fairly represent somebody's idea of the mathematics related to that concept or topic or issue, grab that image, store it, and over the past 6-7 years, I've just been collecting and absorbing what I could. And so I think maybe I won't say too much more except to finish going through these. One way of creating orbit is by attaching something on a string, restraining it. So it's going to orbit because you're somehow tugging, but that's not the only kind of orbit. You can have orbit that is created by containing the motion from the outside.
Are Alistair?
Yes.
Are you sharing a screen? Because we don't see it right
Oh my
now.
gosh, sorry guys.
No problem. That's why we have when people are on there. That's why I'm here. So don't
Yeah.
worry. No, go ahead. Go ahead.
All right.
Let me
So
put that up for you.
great. Okay. So here, what I want to is just put into the head into just say, hey, think this way as well. Is I don't mean only this way. I mean, but recognize that there's two ways to kick the can. You can have an orbit that is restrained by pulling. You can have an orbit that is contained. So that if you have a set of objects that create a container, an object inside can orbit around a empty-ish center because there's a container for them to use to do that orbiting. So that's a just two ways to have your mind think. The other one I kind of passed on briefly is think that motion can go through the same way that it can go independently. It can go through just like a Newton's cradle. That's everybody pretty familiar with that. This one here, you can stack perfect regular spheres at maximum density using a pyramid of 3 or using a pyramid of 4. If you notice the hexagon here, there is a hexagon here, and they're all naturally stacked. These two are the same, but they're a different orientation. In space, orientation is arbitrary, but when you're talking about structures, there's always going to be gravity involved. When you get gravity involved, you've got an orientation. So orientation matters in the macro world, but we know space as being, when you're in deep space, there's no up, there's no down, and there's certainly no west. So I just want to show that there's facets to perfectly stacked spheres, and that's important. So this one here, I don't think I even need to expand some of these. It's just to show simultaneous co-rotation is perfectly natural if there's no friction, and there's no reason to assume friction in at the Planck scale, because friction is an effect of things like charge and surface imperfections and temperature, which don't exist at the Planck scale. All that exists at the Planck scale, again, if this model is correct and not totally off mark, nothing else exists down at this level. No charges, no fluid, no magnetism, no fields. It's just particles at this scale. Everything else at larger scales. This is just we all understand spatial coordinates when they're like a box, right? Easy peasy. People who do astronomy also know that you can work on, you can measure a volume of space by using a sphere if the volume you're going to measure is spherical versus cubical. A spherical approach to considering existence makes sense when you think there's no corners in the universe. So if you were to put a box where that empty sphere is and think, well, we're talking about the universe, it wouldn't make any sense, because then you'd have corners that were farther away, even though they're supposedly the like, I don't know if you're following, but so one of the things to notice about the building block is that it has a stripe down here. It's non-arbitrary, so it just inherent in its physical structure, it has some features that are worth paying attention to. See how the red pushing out is offset, so you almost imagine like a stack of discs, and every second one is shifted to the right or shifted to the left. And so because of that, if this is rotating, you would be, if it was rotating slowly, you would be able to visually tell which way it was rotating. That's polarity. Is it rotating clockwise or counterclockwise? So it has a non-arbitrary, inherently built in, east and west and north and south, because it has a prime meridian. So once you give it motion, the motion determines the east versus west and north versus south because of the inherent shape. So that's important. And the next thing, sorry, I told you there was other magic or kind of special feature coming. So this I didn't find out until fairly recently. Overview. The shape, it's all, a lot of it has to do with kind of like recognizing the features, kind of like walking through it and pulling them one at a time. Shoot, it's not there. I did have a little trouble when I was uploading images. Sorry for the pregnant pause here. Okay, so stacking patterns and cuboctahedrons. This is so when you stack spheres, they have a pattern of natural distance from center to center based on their shape. And in maximum density, they have a stacking pattern which will be 1 with 6 around it, 3 on top facing one direction, and 3 on the bottom facing the other direction. But if these 3 were facing the same as the top, that's okay. It's not going to affect its stacking when there's just 13. But when you put them in a set where there's pressures and that from the surrounding ones, it'll make a difference. So when these turn, if they were all to turn simultaneously with all of their, I'm going to call this the prime meridian, if they all turn with their prime meridian synchronized, they can all shift left and right, and everything goes fairly smoothly. But if one of them tries to turn a little faster, then his prime meridian, or hers, starts hitting in different places on the next one and causing a little extra push, a little extra distance from center to center. So the relationship between them is going to have all of these bars that go from center to center and center to center that have the ability to fluctuate slightly in length, but with some interconnectivity in between them, so that if one shortens, it's going to cause another one to either lengthen or open up opportunity. And so that creates this kind of triple cuboctahedron that has an average in the middle, a larger on the outside, and a smaller on the middle, on the inside. And then when you tessellate space, you fill them up, the average ones in the middle want to hang out together, and the other two do like a interchange, and that's when they're all in motion and stacked. And then so because of the stacking of spheres, then because the model I suggest is stacked spheres based, I chose to look into existence and see if I saw evidence of um, cuboctahedrons, hexagons, or relationships between triangles and squares, like a network of triangles and squares. And that's exactly what the physics world seems to be looking for. When you look at, I think this was Bohr's wave equations, they fit in there very nicely. Um, when you look at uh, Feynman diagrams, I don't know who will be aware of this shape. This is a shape called an amplituhedron. It was conceived by a physicist named Nima Arkani Hamed, or Ahmed. He's actually from my rival high school in Mississauga. So on his, no, I'm just kidding. Okay, that was totally just kidding because he's from Lorne Park. But so this is, and it's being published in like science magazines and stuff. This is a pattern that is derived from Feynman diagrams. So he took a bunch of these and slapped them together mathematically, and he made this. And I say, well, if you look at this one bar here, see how it comes to a point, and you were to pull it out there, you would have a cuboctahedron with the layers in. So if you filled this with these rotating, not always in sync, you fill it there, maybe then it's going to cause these to stretch and contract and stretch and contract. And because they're related, interrelated, that when this one stretches, the other two are going to have, other ones are going to change as well. That will cause, if you think like a bunch of interconnected rods, when one changes and the other changes, that's a curve that causes a curvature relationship. So I'm confident that there is going to be found a relationship between these, but I don't have the math to do that. But also, if you've noticed Feynman diagrams, they have angles, and the angles are not arbitrary. And look, you've got square, you've got 120. There are, which is hex. So you just, and you can see the shape it's building. So this, when I show something like this, I'm not saying, look, proof. I'm saying, all right, so somebody else out there is working on a wavy cuboctahedron shaped something. He says it's related to Feynman diagrams. He says it could be the jewel of the universe, i.e., something that you fill space with it and it explains space and time and everything. So it's like, okay, that I'm not a physicist, but to my eyes, I see relationships there. And that gives me some positive hope. Not proof, call it like circumstantial evidence. But then I looked at snowflakes, and they spoke to me too. I've looked at, dozens, and you will find every one of these bars and patterns represented in one of two types of snowflakes. There are like outies and innies, where this frame or this will be growing outwards from. Sometimes it'll grow in towards the center of it, but they all use this framework as their backbone. And then that relationship and the whole, I'm like looking at pieces of existence to see, do they seem to relate back? Because if all of existence does generate from a particle, within that one particle or the combination of particle plus other its neighbors plus motion, that's your exhaustive set of things that you get to use to create other things. So if again, I'm following the if existence is made out of these and only these, what other things do I see in nature that make sense? And I started to come across tons. Sorry to go off website here, David. I just didn't have time to upload everything. Hope nothing embarrassing comes up. Naked women and shit. I'm really not expecting that. Naked women, that is. No, that didn't work. What am I doing here? Quince. So these are patterns in nature that seem to have some relationship to the properties of the universal, what I call the universal building block. When you look at it, for example, you can put your hands together like this by overlapping where your fingernails are, and then curl your thumbs, and you will come very close to creating that shape. You just won't have quite enough fingers. That's because you have connection to your wrists. So it's like your hands are made to reach out and grab that shape as though it's waiting to be grabbed, sort of. Again, not proof. It's just looking at, hey, oh my gosh, then look at the shape itself. Because that didn't work. See, this is what I mean by patterns, right? Like I just absorb and collect, and you see string theories there and all sorts of stuff. You know what? This is what happens. I try to say too much. I've
No, no
definitely
problem.
I've definitely imparted the basics, right?
Yeah, you did. Yeah.
The immutability. It just doesn't change, which means it's timeless, eternal. And that's important because now we're not looking for time and we're not looking for a start date anymore. There's zero inclusions in terms of forces or energy except as emergent phenomenon. So it's not that they don't exist, it's just that they're not, I suggest, fundamental, that they are generated. So when we see the force of gravity, no, it's a pressured, we float down to the earth rather than getting pulled to the earth.
So
Yeah.
I think we've gotten a really great
Okay.
idea of what you're talking about. I have a million questions myself, so I'm going to start off with myself.
Sure.
We did have some comments I did put up there about the interesting shape. First of all, the idea of a sphere with those kinds of grooves, or spheres with those kinds of grooves on it, and place, of course, just touching each other. That's pretty innovative. Somebody else had mentioned that as well. It is quite a unique idea. And now,
It had to have the ribs. It had to,
yeah,
or
yeah,
else
yeah,
it just wasn't going to
absolutely.
work.
I've never seen anything like that. I mean, the truth is there are different types of theories out there. There's particle theories of movement in space. There are ether theories where particles bash against each other and transmit waves. And there are lattice theories. Now, what I would say is this is more of a lattice kind of theory because what it is, and believe it or not, numerous people I've known who are very intelligent people have come up with lattice theories. And the idea to me is one of the things I tell people. People, for instance, when they think of light, the only thing they think of normally is, we have light, so therefore it's an ether theory. There's only ether. Ether is the answer. Well, I keep telling them, no, it's not. I mean, that's one of the models. Two people I know that were really thinking about what I call sort of a lattice model, where things were more put, and that transmissions were between sort of some type of lattice. Yours is very unique, by the way. Is Ron Hatch? Unfortunately, he passed away just recently. he was one of the people who knew relativity was wrong, and he had patents, over 30 patents in GPS. So he was always going around saying, folks, GPS is touted to show Einstein's relativity, and in fact, it shows the flaws in Einstein's relativity. So he was a lattice person. Also, another person from MIT, a person I know, he's not a physicist, but Bruce Nappy. He also was looking at, actually beer bubbles in beer and soap bubbles and how they work. In fact, yesterday I showed my dad a video of gold particles where they use electron microscope, and gold's so big you can see it, and they were spherical. Another person who's using spheres, who has their model, is Jeff Yee, and he is looking at the nucleus of atoms as being in spheres. And on top of that, I'm just trying to put all this together. There's a group that I'm helping form. They've been in our group, the CMPS, the MPA, for a long time. One guy for over 20 years. They're called the Structures Group, and they're actually starting their own website. I'm helping with them. That's going to be very similar to what we have. And their whole modus operandum is structure. They say that structures are everywhere. And one of the things you've been looking at is the structures. And I think you would be really interested in hooking up with the structure people, because they think about this all the time. And you'll be, and I know lots of people who get into trying to get the physicality of the universe have been dealing with structures. So it's really interesting. Again, I would classify what you have as more of a lattice. It's extremely unique in the sense of that when I saw that ball, I knew, because I'm one of those people. I love theories. I like to collect theories. And it doesn't, because each person brings an absolutely unique vision to, the way the world works. And it's not that you have to accept that this is it, but when it does lots of things and its ability to describe lots of things, you have to take it seriously. Now, one of the things is the thing that makes this work. Somebody made an argument that, I'm going to make its cubes. Like, for instance, this person put in here, put up there, what about cubes? They feel fake. In fact, they could collapse into time dimension, the cube time theory. Well, there's a person saying, well, ha, ha, ha. But the truth of the matter is, no. The thing about what makes the shape that you found, it won't work without the grooves, right? It's impossible. Right. It just won't.
Sorry, I should have said and hadn't gotten to it yet. If you take a four-dimensional gravity wave, the kind that we've detected, so the mathematics of the gravity wave from LIGO with the it's got the ellipse this way and the ellipse this way, and they kind of walk. That pattern, it turns out, is also built right into the shape. So if you take a gravity wave with a wavelength that is a quarter the diameter of the sphere, a gravity wave with 1/4 diameter, you map it onto the surface of a perfect regular sphere, that's what you get. So it's a medium with ribs, that makes sense, with the gravity waves are built into the balls, which means that they permeate existence. So we're not looking for gravity; it's built right in.
Right, and I think one of the this is a person I was talking about. It's a very interesting model because of the ribs. Here's another
and spine. Don't forget the spine. That's a backbone down to one side.
Right. So here's a person. He says, "Thanks for the talk." So it's kind of like a string theory. Well, the only thing I would think about, I just want to say something about the string theory. The string theory, for those who don't know, I never interviewed anybody from my movie about string theory, but I did follow them closely. The string theory was a mathematical exercise. That's it. No physicality. In fact, the people who are the original people of the string theory, I saw in the 1990s when I lived in LA, it was close to Caltech. Caltech had a public day, and the public day they were looking at different things. People were talking, and some of the people were talking about string theorists. The string theorists, who were the original people, I saw an interview. I can't find it. I don't remember if I saw it on TV at the time or if it was in an article. But they said they were extremely disappointed and sad because they knew that the string theory was never intended to be a reality of anything. But the problem is in science, people take the mathematics, get into the system, and then what used to be literally by the creators themselves, emitted totally not a real model of the universe. They wanted to just see what they could do is they could get everything from one thing, a one-dimensional string. I don't know. It's just absolutely absurd. But what happened is they took it to the absurd length. So those, no offense, those people who are looking at string theory, in my opinion, you have to throw it out because the people who, it's all math. And so, I mean, he's saying, but it's like a rib, and that's my opinion, Rainier. I'm not bragging on you.
I can address the question asked.
Yes, no, that's okay. I was just making a sub comment on the string theory.
Right.
I
Yeah.
think people take this as a serious, in my opinion, should be just thrown out. No, but he did ask a second part, which is, Alistair, have you looked
Yeah.
at Nacium
I'd also
ceramides?
like
Okay.
to address the string theory aspect
Yes,
of it,
okay.
and then I'll show you
Absolutely.
why. So I'm going to share screen again for. Oh, do I have that? Oh, I already am.
Yeah, I can. I'll put it up there for you.
Oh,
Just
please, yes.
as soon as you're ready.
Yeah. So strings, Hopfians. Where did I put them?
Again, for those who are watching, he actually has all of these things on our website. You can go to that. It's at naturalphilosophy.org. So if you're interested, he has a group there. You can make discussions there on our naturalphilosophy.org and see all these diagrams. So why he's bringing that up.
And I'll add more because
Sure.
I have lots. I just have trouble. It takes me time to filter.
No
like
problem.
say,
No problem.
Okay, this one doesn't. This one is too
Sure,
many.
sure. But again, this is a group that he has
Yes.
formed on our website, and that's the idea of our organization is that people can find groups and discuss. If you have your own theory, you can start a group about it so people can learn about it. So that's what we're looking at right now at naturalphilosophy.org and the group called Planck Mechanical Theory. One real simple question is you call it Planck. Tell us why.
Because it's at the Planck scale. So, and lots of people come up with names. I just try to be pragmatic so that way the name says what instead of the name just being some arbitrary name I gave it. I'd rather have descriptive. So string theory, right? This is what I wanted to address. This picture here. So when she moves, pieces of her body are going to describe motions. And so if I was going to say, how does string theory interface with a Planck mechanical model? If you were to pick a point in the Planck particle and follow it, or the, as they're doing their wobbly orbit, follow it, then you'll I'm guessing the string theory pattern should emerge if string theory is mathematically valid, which everybody is of the opinion. So but I don't know if it is or isn't. But
well, I think part of it, though, Alistair, is the mathematical side.
Yes.
Listen, mathematics and physics are not the same. And I think, you can have a system that could describe the entire universe. But the question is, and the thing that we always are asking ourselves, is this the real physicality of what's going on?
Yes.
Because a system can be completely divorced. And I'll give you a good example of that. So, electronics. My dad is a 40-year veteran of electrical engineering, very good one, and he used a ton of equations. They use all these equations that work very well, but we have a model of the universe that we're trying to get the reality of what's going on there. It's very different from the equations that they are using. So we have to be really careful in science not to mix up in interchange mathematics and physics. So when you talk about, well, it's mathematically sound, it doesn't matter in physics.
No, I'm not saying string theory is mathematically sound. I'm saying if it's mathematically sound and if my concept are correct, then the two are going to have to meet. And if they meet, it'll be because the strings are following the balls as opposed to the strings actually being there. They are the contained motion. The strings are contained. They are patterns They're not fundamental in any way, shape, or form. They don't exist. They're descriptors. If
Right.
they're mathematically accurate, and if a Planck mechanical medium exists, then
Right.
that's
I have
where they
another
would.
yeah, I have
Sure.
another
Yeah.
question. I think that because we have what a little less about 25 minutes left.
I'll try my
This is a
best to be
question. This is a
non-verbose.
no problem. No, that's not hey, when you have a show like this or a well show, it is somewhat of a show, but a conversation like
It
this,
feels like a show.
the worst part is not having a person who doesn't say anything. So here's just a general question I have. Okay, when I'm looking at the model, again, the spheres part and the groove spheres, very innovative. I think that's got a lot of, I mean, it can do a lot that other theories cannot. One of the models cannot. One of my questions is, however, is you have the sort of lattice there of these balls, and they're rotating and that kind of thing. How is it that you have any object that moves through the universe? I'm moving here. Now,
Right.
is that a translation of the rotations in that lattice? What is that?
I suspect that the scale is so much larger. Like
Yeah, of
it,
course. We understand.
a quanta is like 1,000 times bigger or something like that. So you don't see. So I need a visual here. This one, I think. And my depiction is not a complete depiction. So this is not as complicated as it would need to be. I would put a spider web that runs through and kind of interconnects
Hmm.
in between tubes, twisted tubes. They would look like if that. So I consider that to be like what you see there. That spin field would be like outer space, but
Hmm.
it doesn't want to stop being. It has a layering to it because of this. So it's doing all this, it's balanced, and because it's balanced, things can pass through it simultaneously going multiple directions without interfering if they also are in the right phases. So you get
Hmm.
like a peak and a valley crossing at the right time, they're just going to go right through. But so then if you take that sort of mattress looking spin field and then you bend it into a ball so that the inside starts to connect to itself and create a sort of, again, but this is, you're thinking of this as floating within the mechanical
Okay,
medium.
so basically what you're saying would be that could be organized groups of these balls that move
Absolutely.
within the ball field.
Yes.
Okay,
Yes.
that's interesting. That's interesting. Yeah, I've never heard that either. That's actually an interesting a
And
way to
and
to
and
say that would work.
and when I started to think that way, seeing like bent mattresses being the objects and they're going through the field that's not bent, um, I looked for, does that kind of feed back to, does it make sense? And what I found, because I was looking for, does gravity interfere with itself? Because
But
we're
what
looking
is
for,
what is gravity in your model?
um, so it's a wave. But it's a, I would say gravity is like, it's always, everything's always doing this and always doing this. And you've got
It's like a Brownian motion.
omnimotion. Yeah. Right. Brownian. So every direction. But when you have something that wants to be like this and then you bend it, depending on the radius, you just make these tiny little cracks. And so when something is bent, it has a different density than when it's flat. And so things will float down towards centers because they're shaped like this. So they're going to go down through. If they were shaped like this, they wouldn't. And but because they're
No,
bent,
when you say move, again, are we talking about groups of the balls moving together?
no, the balls never act as an assembly. They're just the generator of the field, and the field itself doesn't contain the balls. It is within them. Like it's like the tsunami doesn't carry the balls, doesn't carry it will cause some relocation when it passes through, but it won't grossly relocate the water molecules when a tsunami goes through, right? When a tsunami goes past Hawaii, it's like a ripple, and Hawaii doesn't really notice, but it's still the same. But when it hits the shore of California, it's not Japanese water wiping out the coastline of California. It's California water, right? So
Mm.
same with the Planck scale is like the ocean, and all of the things that we experience, like quanta and elements, particle, like our macro world, they're all tsunamis. They're not.
Are you saying then they're waves? Because one of the things I'm hearing though is
Yes.
a couple things though. I'm hearing different things too. I wasn't understanding. For instance, you were saying that sort of like objects that move through space, like me, those are balls that are sort of together and then they move through the field. But then you're also talking about movement of the waves in the field that are not sort of that are ball to ball, not groups of balls.
Um, yeah, because this it's the scale, right? So I just don't see the balls individually being a part of anything at large scales. They are just the medium. And
Is light a part of that, or this too, or
light
is it?
is light is I would say um this looks a little rude, but light is two is two twists and two counter twists. That's light. It's like a scale, a frequency, a size. So you got a wave, a photon is traveling through the medium and is bigger than the medium, and how big it is what color it is.
Oh, okay. So it's actually. Oh, I'm sorry. I guess so. It's actually like the Newtonian model for light.
Well, it's
Well, no. Well, maybe you haven't read about
light.
that, but
Light is propagating.
No, but Newton proposed that the different frequencies were different sized particles.
Oh no, I'm not calling them particles though.
Well,
They're like
no. Regardless, what we're going to call them.
call it like a an energy shell. I see it as it's got like
Well, energy is a concept, right? But I'm so it's really more of it could be a movement. It could be the movement of them moving. Yeah, I understand. Okay, but what you're saying is your model of light is going to be Newtonian in the end. That frequency, or is really caused by the size. Is that right?
yes, light is the scale.
Right. But you were saying the different sizes were the different wavelengths or
Different wavelengths. We
colors.
know that a
Right.
wavelength is a different length, right? We don't know that frequency. Do we know it has a size too? Yeah, it does. So
Well,
yeah, it's
well,
just
knowing it,
scale.
no, yeah, the size all depends on the model. It really
And
does, right? I mean, if it's a wave model like ether model, it's going to be described in one way. It's going to be really real waves in a medium like water. And then if
yeah,
you're going to have, or air, if it's more in your model, then of course you have several options. It seems to me you can either have the actual balls transmitting motion waves, even if the balls aren't moving. That
yes.
could be that could be one
Um,
way. You're also talking about maybe a photon is a bigger particle made
and
of balls that move through. So you have obviously an
it's
ample way.
I want to kind of suggest a different approach. Like instead of thinking light as going from here to here, it's like this frequency affects the one beside it, which affects the frequency beside it, which affect. So it's the frequency. It's the change in frequency that does the traveling, not a thing that does the traveling. I
Right.
think.
Okay, here's let's get some questions here of the people who are attending. So we've had an attendance between 20 and 30 people coming in and out of our three places.
Sure.
So
Yeah.
here's a question from Adelard. If all the spheres are connected, how does the motion of one not influence every other sphere?
Because the there's variation in the rate of rotation, and they don't just have a rotation. They have, I don't know if how many people are familiar with the Milankovitch cycles. So there's like orbital, and then the ellipse that it's orbiting around can rotate, and then the Earth itself has like tilt that varies, and precession as it goes around or something. So those kind of motions, if you had a containerized, so you've got 12 containing one, if you expand those 12, give it a little more room to what's inside, it can act differently. It has different options. If everything is like locking it in place, it would have very limited options. But I don't suggest that there are like these gaps with free acting. No, everything is together, but it's the little pieces build the effects at larger scales.
Mm-hmm.
So
Okay.
nothing ever needs to roll. If 1,000 things roll a little bit, it'll create a large thing that seems to be rolling because all these little pieces of roll that are making it seem like there's a big roll. And so I would say that it applies to that's why there's opportunity for variation.
Okay. So here's another follow-up. I think it's Adam is saying, Adam Lohr says, in other words, if one sphere rotates clockwise, it will move that sphere next to it counterclockwise, and the next to that clockwise, and so on, right?
No, in a friction-filled array at our scale, that would happen. You can't turn all the balls the same direction, even though they're very, very smooth surfaces. They don't want to turn all the same way. But when there's no friction, they all go clockwise.
But if there's
or
no
they all go counterclockwise.
but if
Doesn't
there's
matter.
no friction, how do they interact? How the grooves transmit anything to another one?
Because the pushes aren't push left, right, and they're not push up. They are like a shoulder shove. So this one shoulder shoves that one. And while that's happening, on the other side of it, it's getting shoved down because they're like this through, it's like these two are like this, then the next one is like that, and the next one is like this, and they're constantly going like this.
So they're frictionless,
while
but
they're
they
rotating.
they can transmit kinetic energy.
It's like a forward and upwards motion that it pushes up and forward.
Does
Well,
that well
more
if they're frictionless, then well, I guess because they have grooves, even if they're
exactly, yes, the
frictionless,
grooves.
yeah,
And so
yeah.
the motion is not like, it's not this one causes this one causes. No, you got to think of them all as having a built-in semi-cooperative motion. So they all are already, like when you think about the ocean, you don't think, well, I could push this one ocean particle, push the next one. They're all already moving. So you're hitting something that's already moving, and you're just going to transmit the hit. You're not going to transmit the whole. Does that make sense?
No, yeah,
Like
yeah, okay.
when you poke one one water molecule in the ocean doesn't make all the other ones move because there's some play.
Okay, so he's saying here also there in what way can a sphere influence one above or below it?
They never can overlap, right? So you got, they don't go inside each other. They can, their actual physical part do not overlap, but the grooves do. When you see the shape, you see on the top it's got the two arcs.
But it's a sphere on the top though, almost, right at the very point.
It's got two arcs that bulge out. I call them the North Pole, the two North Poles. It's like it's got a bipole at the top, and they're both arcs, and one is dominant and one is not dominant, smaller.
Mm-hmm.
And
Okay.
so those are opposite from. So there's like the dominant arc and the I don't know what you call the complementary arc. The one above it is going to be reversed. Is going to have the heavy arc over top of the light arc, and the light arc over top of the heavy arc.
Mm-hmm.
So they've got the same sort of. If you twist them out of sync, they're going to have to lift up against each other a little bit, which means they're now pushing against the rest of everything pushing back down. So it takes a lot for them to get out of line.
So if there's no friction, I guess they
There's
would turn. How do
universal
they
conservation
turn?
of energy.
Yeah. Okay. I don't know. James Keen, you're there. I don't know if you're listening in. Did you want? I have one person in our green room. Did you want to come up and say anything, or are you okay? You can shake your head, yes or no. No? No? Okay. Yes, you do? Okay. So what I'm going to do is I'm going to bring up James Keen
Sure,
because because we have the ability to and people are sitting there. We try to get
absolutely.
everybody. So James Keen, I think he's one of the regulars during this
Yes,
Saturday before I came in here and blew up stuff and gave poor Franklin some time here. So let me bring him into the group here.
sure.
And hey, James, how are you?
I'm fine. How are you, David?
Very
And
good. Very
Alistair?
good.
Good. I'm great. Thank
Pleasure to
you.
be here. I just have two questions. Thank you, sir. I just have two questions. What is the size of the ball? For example, its radius. I guess it must be pretty small if you're talking about Planck's
Yes.
constant in
And
there. And my
I don't,
second question is, does your idea of a prime meridian for each of these balls sort of imply an absolute spatial reference frame? You talk about it as being a solid piece of concrete, this array or lattice of balls. Are we really talking about an absolute reference frame? I find that very intriguing. So those are my two questions, sir, and I'll sign off and let you answer. Thank you.
size, I don't know the exact size, but it it's all internally relational anyway. So if they were 2 miles across, they would still work. They'd just make a bigger universe. And if they're 1 millimeter across, they still work. They just make a smaller universe. So I didn't worry or focus on size. I worried about the relationship, the mathematics of the waves, the ratchety frequencing pattern versus the smooth frequency pattern. I worked at it that way. What I suggest it does is it establishes the relationship between um, different frequencies. So we have a thing called a Hamiltonian. It's a bunch of potential layers that are all like fluid. No, that's not the right way to go. Um, size. So from the peak ridge on one side to the peak ridge on the other, that's a calculatable finite concrete distance. From it to the valley on the other side is a different distance. From it to the center of mass is a little more complicated because a wave deformed sphere has a complex center of mass. It's not a single point in the middle, it's a shape in the middle, like those bowling balls I showed you. And I'm confident that we're going to find that it has a twisty helical, and I wish I could calculate it exactly. I have to try and intuit, and I might not be envisioning the center of mass being exactly correct. If anybody knows how to calculate center of mass from an equation, I'd love that to get me the virtual inside. Because if it happens to say look like a DNA strand, that's going to be huge. Um, so the it sets up relationships. The frequency, the small frequency, if you're going around the bumpiest part versus the diameter of the smooth versus it sets up relationships, and those relationships are ratios, and those ratios I suggest produce the Planck ratios, and then it's light that provides scale along with those ratios to give us the specifics. But those specifics, see, if there's a medium that can slightly expand and contract, then light in one part of the universe might be slightly bigger than light in another part of the universe. And so that's why I say light provides scale. And I'm not talking a lot of variation. I'm talking minute amount. But light is what provides the scale at the scale of existence within the medium in a locale is defined by, if these were more separated, green would be a bigger size here than if the density of them is more compact.
We got
and that might be garbage.
No problem. No problem.
It's an effort to.
Let me
Sure.
ask you two other quick questions.
No absolute space frame. Arbitrary. Up is
Okay.
nowhere.
I know, because one of the things relativity, obviously, is people who are interested in relativity, right or wrong, is the absolute frame. I have a couple other questions. I think just general questions about your
Sure.
model. Two things: are these elastic and plastic? These particles or spheres?
Rigid.
Rigid. Are they perfectly rigid?
Perfectly.
Okay.
Immutable. It's
Okay.
like they're the
Gotcha.
only thing I've ever come across that could actually take advantage of the existence of the word immutable.
Okay, and then
Because
the
what
other
else is
question.
eternally non-changing?
Then I got one of the confusions I get with that though is if these are the particle, the spheres that really describe the universe, you're talking about something that's subparticles or pieces inside. Is that what you're
No,
talking about?
no, it's a
What's
unibody.
Okay, so the DNA strand you're talking about is not inside.
It's
It's
the
because
center
you're
of
talking about
mass.
the bowling, yeah, but the bowling ball, for
Oh,
instance.
no, no, I didn't mean to. I was just talking about how there can be a shape embedded, but in that case, it's a physical shape. I was talking because the outside, um, see, like
Is
if your shape had like a big hunk up here, your center of mass is going to be up here,
Okay,
not
but I have a
here,
question
right?
though. Okay,
Yes.
here's I think the philosophical conundrum about that, and that
Okay.
is if you have a center of mass, that means things are not the same density.
It's uniform density because it's the shape that's important, not the
But okay,
and when I said mass, I'm using the mathematical
right,
calculation of,
understood. Yeah, sure, sure.
so I'm getting its center of
And is it
matter. Let's
if
call it
it's not
center
made
of
up
matter.
if it's not made up of parts, right? No
Right.
parts.
No parts,
Then
no.
you no matter how much you shrink down, let's say you could shrink yourself down, you could never find a hole. Now, to me, that would be an infinitely dense object. That's correct?
Okay. It wouldn't. Um, Density doesn't matter because what's like if it was the density of plutonium, or if it was the density of a a sponge ball, it's got no flexibility. They're supporting each other by way of being rigid. They're not supporting each other by holding each other up against gravity. There's no gravity. They're not trying to go this way or that way. They're just doing motion. They don't know what up and down and heavy and light. And
Are the particles identical?
yes, absolutely identical. That's what made the most sense. So that was what I envisioned, and that's what I have tried to test or explore. I didn't explore tossing in anything else. I was looking for, could one thing explain because if I introduce different shapes or different sizes or different anything, then you have to, how do you explain the differences in the quantities? Are the quantities local, non-local? Whereas if you've got a unit that's universal, then everything comes from something else, which would be coagulation and dispersion of collections of pieces of energy that want to go together in certain ways because of their underlying properties,
Okay.
is what I
Okay.
would suggest. But
Okay.
it's my best guess.
Right. Understood. Okay. So we're getting to the end of our time here. I'll just give, I know it's not easy, but try to give us an idea of where you're going.
Um,
What are you doing with what you have? I know from talking with you, you have a very long journey, and to talk about the journey, but do you have you as a person who has this model, what are you doing today? Or is it more just like I discover things and sort of, keep putting it in? Do you have a specific goal? Because one of the things people are asking in the chat is, do you have a website? Where can I read
Yeah.
about this?
Um,
Do you have any plans to maybe organize this at least so people can get it? Because again, it's not important that people have to accept your model or not, but the way you're thinking and the systems and the things that you're coming up with are very important inspiration for others, whether or not they maybe take you up on and go on the journey with you with what you're doing, or that journey will, something that they'll pick up that they can use themselves. Is there any plan for you to formalize this, a book, a website, or what?
yeah, I didn't get to it, but one of the folders in there is called, in my CNPS collection of photos, is called I Wonder. And that was me thinking about, hey, maybe I'd write a book geared towards like 3 to 5 or third to fifth graders, because we all hear, if you can explain it simply enough, then you understand it well enough. So I want to see if I can, just by saying, well, if I turn this one and I don't turn this one, it's going to go like this. And if I turn them both, then they're both. I think that it could be walked through well enough with the right visual props that a book could be made for a common denominator. So, because if I try to write for, PhD physicists, then I'm going to use the wrong words, and I'm going to get told that it's wrong, because that's something I don't even actually need to propose. I can provide the shape and the properties, and then there are people out there in the world who know what the universe is supposed to mathematically equal. Physicists, we call them. And they know what we're heading towards. If they see a shape that they thought is worth investigating the ramifications of, you can do what's called like an interference study. I just don't have that ability. Like, I worked in automation, and we can, I know there are software out there that says, if you've got this, this, and this, and you want to move a robot, you can choose, like, you can learn whether the robot's going to hit something without actually having to physically test it, because it can mathematically calculate it. And so we have that, and like, so there should be ways to, if the shape has merit, there should be a way to confirm it mathematically, and that's what I'm hoping for, is to either, I don't know, there was like a couple of teams of physicists in the past where one guy came up with ideas and the other guy turned it into mathematics, and together they gave something to the world.
Right.
So,
Understood. Understood. I think it would be an interesting step for you and worthwhile to try to organize it a little bit, because
yes.
I think one of the problems is, and especially with today's world, people don't have as much time. They get so much bombardment of information that it would be nice to be able to go and sort of walk you through. Now, for those who don't know, the CMPS obviously has a bunch of ways you can do that. You have the website. You can make your own website. We can even help people with that. I know you said you can do that yourself. We have the groups where people can ask questions. We even have LearnDash, which is something that we subscribe to, which is paid, and that you can make courses on. So you could actually walk people through things. So there's a lot of different things. But I think, in my opinion, you should really spend some time, Alistair, to get these things somewhat organized so that people can come and look at your stuff and be inspired by your work and that kind of thing. So I would really recommend you do that. But I want to really thank you for coming out here. There's nothing harder. People can always criticize anybody's ideas, but there's nothing harder in life as either an artist or a person who's working on new ideas for science to get out there in the real world and put yourself forward, because everybody can be a critic, but not everybody can get out there and put themselves out there and put out what they really think is happening. So I do appreciate it. It really made me, there was a lot of things that you have in your model that remind me, and I can see a lot of parallels, the spheres, the structures, the uniqueness of your spheres having the grooves do actually introduce an ability to do things in a lattice that a lot of lattice theories and I guess theories, models, sorry, lattice models can't do. So I think that's very interesting. I think it's really tickled our brains. And that's the idea of this group and our channel, my channel, Dissident Science, is to get people to think a little outside the box and think in a way that now Alistair thinks of the world in this way, and how that will, make our brains be tickled in a way that will really make some things click. So thank you so much for
You're very welcome,
coming
really,
on.
and thank you very much for not just for today, but for the whole setup and all of the effort. I know that kind of thing takes. And
oh no,
kudos.
No, thank you very much. So I'm going to take you down now, but thank you very
Sure.
much. And
You're
anybody
very
who
welcome.
wants, if anybody wants to get in contact with Alistair, you can do it on our website. He is there a lot. He's been putting up pictures. You're going to go to the front page and see all kinds of stuff there. I encourage you to go to our website. Again, that's naturalphilosophy.org. Sign up, get involved, read, look at it. We also have some other websites, the wiki website as well. You can take a look at a lot of our work there. And of course, we do have the our YouTube channels, which you're watching, and I want to thank my YouTube subscribers. I've been busy on my own job and stuff, and I promise you, I've got a number of videos in the works that some of my commentary videos with graphics and that. I know a lot of people are waiting for those, but I do appreciate, and I think it's very important for everybody on the Dissident Science YouTube channel to get their brain tickled by some people who think outside of the box. Whether you agree, it's not whether you agree or you subscribe or you think this model of Alistair is all wrong and you think, oh, the universe doesn't work that way. That's not the idea. The idea is to allow for people to freely come up with work on things, and it's a free world. Your mind is free. You can think of it. You can come up with your own model of the universe, and we should encourage that, just like we encourage people to be free in art, to be free in software, to be free in business. We need to do the same thing with physics and cosmology and get out of this idea that there's only one answer to the question. There can be many models describing the same thing, and we know that because we have engineers using equations all the time that have nothing to do with physicality that people use. So anyways, I want to thank everybody for coming, and I see my daughter is playing piano now, so I'm going to get out of here. Thank you so much. And if you miss part of this, I would say, get yourself out there, look at our YouTube channels, and you can re-watch this. And I want to thank everybody once again. My name is David D. Hilster. I am your science therapist and trying to get you to the promised land of becoming a critical thinker. That's what I'm trying. I'm not trying to tell you, don't believe anything I say. Look it up yourself. Ciao for now.